Okay, now it works. Sorry about that. Every once in a while, for whatever reason, my microphone gets lost. Um, just not a lot of fun. So anyway, let's get started. Um, First of all, Burn of Sigma, thanks for joining. Um, and hello. Um, Welcome to the stream. We are, oh, first of all, it's looking to be better outside. It's been kind of rainy and crazy the past few days here. So today looks pretty good outside. Um, I'm happy to be back here. And so Friday night, or Thursday during the stream, we started talking about some functional programming ideas. And one of the things that I want to do with this project is just I've always wanted to ban undefined at the very least, but maybe null from a project, and just see what that would do to my code, and how much of a trade-off am I really making if I do that. So you know we started talking about some functional ideas, some ideas about monads, and in particular the option or maybe monad. There are a bunch of other monads that are useful, and helpful. And monads are a whole category of functional programming. Um, and the meme description of monads is, it's a category of collections in the, I can't even remember, it's endofunctors, and right. Um, Collection is again, this is very, very, very simplified. So I do want to start out by saying, we're simplifying a lot here. And functional programming is an amazing rabbit hole to go down. And functional programming is a powerful tool to add to any programmer's toolkit. Um, some people will say, "Oh, you've always got to be functional." Some people will say, "No, you always need to be, object oriented," or who knows, right? Who cares? Um, as far as I'm concerned, you should understand all sorts of different types of programming paradigms, so that you can make informed decisions about when to use which kind. Um, Functional programming is a powerful tool. It's a tool I reach for often, because it is very powerful. Um, there's a popular post on Twitter today where somebody is bashing on one of my favorite books, the Gang of Four book. The design patterns. Um, I like design patterns not because I want to reach for them to implement them, but because design patterns give us a common language to talk about what we want to do. And then, if I try to describe, um, a facade to you, um, we may have different understandings of what I'm describing, right? Um, However, if I say that we're going to use a facade, most people immediately understand what a facade is, right? And so we have a common starting point. And whether or not we implement it the same way or things like that, at least we have a common language that we can discuss, and we understand the pros and cons of using a facade, right? Um, and that's the power of design patterns, is that they give us as engineers and developers the opportunity to discuss things in a way that everybody has kind of a common understanding. It's the same way with functional programming, right? Um, and this is, I'm going to do a lot of simplification today to make it easy to understand what we're talking about. Some of this simplification, um, it's always dangerous when you start simplifying things, right? Because there will always be somebody who's like, no, what, right? And they're absolutely correct, right? Um, but for the sake of giving us common understanding, sometimes simplification helps, right? So in the case of monads, what's a monad, right? A monad really just describes um, a collection of functions that refer to themselves that describe a way to get from one state to another. Um, That's that's really all a monad is, and that sounds a little bit confusing, but um, endofunctors, for the most part, in TypeScript, we can think of endofunctors as functions. Um, and so endofunctors just means functions that refer to with oneself, right? So a collection, what's a collection? A collection is a way to describe a bunch of things, right? Um, and so a monad is a collection of functions that describe how to get to oneself. And one piece from the meme description that's always left out is that it also includes the identity function. Um, and what's the identity function? The identity function is just a function that, when it's called, returns, that thing. And so often you'll see, the identity function is a function that takes, type T and it returns type T, right? It just returns itself in a lot of cases. So when we're talking about monads in functional programming, what we're talking about is a way to create something that, when you use those somethings, they return the same thing, and it allows us to do some powerful chaining and stuff. I have some libraries that you guys probably saw me looking at before we started, and I found one that I think we're going to use. But I think before we get to that point, let's implement our own option monad, and it will be very naive implementation, right? Now, once we do that, then we'll bring in the library. But I think implementing our own will give us an understanding of what the monad is trying to do, and then once we've done that, we can replace it, right? Refactor our stuff with something that's a little bit more robust. And the library that we're going to be using, you guys probably saw me looking at it beforehand and looking at the code, is just the monads from Thames Technology. And it just gives us some powerful stuff, right? We get the option type. But one of the things that they add is this match function. We'll probably add a match function. There's another function that we will add called the bind, which will give us the ability to chain these so that we can do some stuff. Some functionals like FPTS, which is a big one. So if we look at TypeScript functional libraries, so FPTS is a really big functional programming library, and it also includes things like option and things like that. So it's got option either, it's got IO, task, functor, applicative, and monad, right? I don't know. Maybe I'm still trying to decide on the library. It'll probably take us long enough to implement this so that we don't have to use the library. I may use FPTS. I do like FPTS. There are other functional libraries out there, but one of the things that FPTS gives us is the pipe function. Oh man, now we're blindingly bright here, right? But option gives us some powerful stuff, and so there's tap, that we can use, and get left, get right, and things like that. So there's a lot of powerful things that we can do with monads. And the reason I want to implement our own is because I want to show you some of the power of monads and things that we can do. So ours might be a little bit different from the default implementation for the sake of education, but it should help solidify within our minds, kind of what it is, what option is, what a monad is, and then why you might want to use them. And before the stream, I did upgrade all the packages. I just wanted to make sure that we update dependencies. Let's dive into some code. So first of all, let's go ahead and just stop the build process. And then we're going to launch WebStorm. And there's still this thing, you guys will see it, that there it is right there. That's NX. So we're going to move our stuff off the screen so that it doesn't take over so much. Make sure I'm watching chat. And let's get into it, right? So the first thing we want to do is we probably want to generate a library, and this library will be our optional library. And it's going to be naive implementation of optional. So we are going to let's go to NX and generate new library. We're going to generate a new library. This, we'll just call it naive option. We'll see where this gets placed, and it is taking over on the other screen. So it's popping up a whole bunch of command prompts as it's doing this. It is one of the frustrating things about NX, but well, not always. It's only on Windows and only when they spawn processes that aren't marked in a certain way. So libs naive option looks good. I'm good with where it's going to put it. So that looks good. Let's see. I'm good with where it's going to put it. Lazy, I'm fine with. Well, we aren't going to be lazy. This doesn't have a parent. We aren't going to make it publishable. We aren't going to add routing. You don't need a module spec. We don't need Tailwind. Change detection doesn't matter because we aren't going to use change detection. Display block doesn't. Flat doesn't. Import does. And so this is going to be at, and we're going to do modular dash state slash naive dash option. That's where we're going to import this from. Inline styles doesn't matter. Inline templates doesn't matter. Linter, no. Prefix doesn't matter. We aren't going to be using selectors. And everything else looks pretty good. We're not going to skip tests because we do want tests for the stuff that we write. Standalone stricts are fine. CSS is fine. Tags we'll worry about when we get to the point where we're going to be using tags. So I think we're good. Let's go ahead and generate. Oh, wait. that succeed? This is taking a little bit longer than I would expect. Actually, a lot longer than I would expect. So let's see what's going on here. Window that just popped up. Um, so there are some processes being spawned. Oh, WebStorm has a whole bunch of console windows and node processes open and command prompts. Interesting. Let's kill a few of these. Whoops, did I just kill WebStorm? Oh, that's fun. I just killed WebStorm. Probably I was going to say it's probably a good thing. It's not really, because now we have to go back through and regenerate all of that stuff. So pop this open, go to our libs, NX generate. Uh-oh. Okay. That tells me that NX is probably in a bad state. So let's take a look. NX, or let's npm exec NX reset. So the NX daemon is probably in a bad state, and that's what's causing our issues. So now that we reset it, let's see if I can generate the library now. There we go. So NX got into a bad state. And I've only ever had this issue on Windows. But a NavieOption. Thank you for popping windows over the top. Helps. Again, we're in a weird state. I'm going to see if I just reset the daemon, if that causes it to go forward. Change detection, display block flat, import path. Actually, there was one thing we wanted to change. I'm Let's copy this command, bring it over here, see what happens. if we go to the libs directory, and then we run the command and we do try run flag on it. Oh, and I need to pnpm exec this. Operation not permitted? npm exec nx. So that works. npm exec nx g. So that one works. So what is broken here? We're generating an Angular library using the NX generator. Oh, no, this is pnpm exec NX generate. Command NX not found. It can't open the log. That's the problem. NX reset. Probably have something. Failed to reset. Failed to clean up the workspace data directory. And that's the issue we're getting up here. So we have something that's locking that data directory. Got a whole bunch of extra node. Wow. I've got a whole bunch of extra node processes. Let's perhaps if we kill a few of these. Okay. Now let's see if it allows me to reset that. And I don't know what causes those node processes to stay. Yeah, so now that works. So now if I run this should work. It's trying to. I just killed the process that was doing that. Let's see if I've got any other weird processes going on. Let's clean up all of my terminal prompts. That killed that. We'll go ahead and restart that. Let's shut this down. And is a little bit frustrating. I wish I knew what caused it to get into this situation. Because it is very frustrating. I also don't know what keeps popping open that window. That's another thing I'm gonna have to track down. There is one Node.js process that's out there and still trying to do something. Oh, that is a lot of console hosts. So, you know what? I should just bring this over so you guys can see what I'm doing. You're not just staring at a blank screen, but I don't understand why. Whoops, not what I wanted. Just don't understand why we're leaving all these console hosts. Like, what is leaving these open? You know, because one of these probably has a lock that is causing the issues that we are running into. I guess the other thing I could do is go about it through the unlocking tool. But this actually gets to be pretty frustrating, and it's a Windows issue. Um, it's just leaving zombie processes running. You know, this used to happen. Well, you can get into this state in things like in Linux or even on a Mac. Like I have this issue sometimes with Mac, where um, oh wow, there's a whole new version that just released right after I updated before the stream, but I'm not going to worry about that. But there's an issue where if I leave VS Code open and then do um, you know do something large with my code base, there's an issue with Husky. So if I do something with Git, leaving VS Code open, um, then file handles. I'll run out of file handles, which does fun things to like my browser and all sorts of fun things like that. Um, there we go. So now it's finally running. And there we go. Um, so we definitely don't want to do this here. We want to go into the libs directory. And then we'll run that dry run again. And I'm really not sure what causes the whole issue. So there we go. I think this will do what we want it to do. And then once this is done, so inside of here, we should see. Ah, put it in the wrong place. That's okay. It told me it was going to put it there. I just didn't believe it. So let's go ahead and get this going. This is just a little bit frustrating, and I need to figure out just what causes it. I may just need to move over to like WSL or something like that. Um, but we already are missing. There's the model. That's what we had open before. And then we added NavieOption, and NavieOption sits here. So we're going to use an NX generator to move this. We're going to move it to another folder. The folder is going to be libs. lib/naive-option. So yeah, so it's going to move all the stuff, and then it's going to update our base, and hopefully the rest of the stuff. This should be good. I'm curious what other options are here. New import path to use, I'm fine. These are all good. And yes, we do want to update. So if we generate this, and now it's working, and it's busy, huh? So did that not get moved? Oh, there it is. There's nothing here. So let's go ahead and delete this. And NavieOption looks to be okay. We'll go ahead and verify stuff, but okay. I think we're in an okay place. So let's go, and first of all, we are going to just take a look. So the ESLint, we can stage everything that's NavieOption. That stuff's all new. Then we can look at tsconfig base and modular state NavieOption. So it didn't update this file, but that's okay. We can fix it. So let's go pop open our tsconfig base. Tsconfig base. Oh, nope, was not. The one we want. And inside of here, NavieOption is actually in libs/NavieOption. Source index.ts. So if we look over here, and that is, it's got the whole node modules open because of what I did. But if we look, so cancel that. We aren't moving things again. Source index. So the path here, we can actually copy this path. And we can paste this right here. That is the correct path. So now we've got the right path in place. So we're good. So now we can commit that file. And we added naive option library. Okay. So make sure. Oh, wow. So Bro, we got to stop using Windows. I know, Michael. It's frustrating. It is very frustrating. It's Windows 11. And hey, Marcus, welcome to the stream, man. Thanks for joining us this evening for you. What do you mean by modular UI and state? Absolutely, Pulak. So the idea is to build components that are composable, and that's a solved that's a solved problem um, in any web framework, really, right? Composable components are solved. I mean, HTML is composable, right? Composable UI just basically means that our components can be put anywhere, and components could exist within other components, right? Completely modular. So the interesting part is a modular state, right? How can we build a state that is compositional, and that we can take pieces of state and compose them to generate larger pieces of state that itself could be composed, right? And so that's what I mean by composable or modular, right? Very, very similar to, when we think about modularity, it's often compared to things like Legos, right? Where Legos can be put together in any order. It doesn't really matter as long as you follow the rules of the Legos themselves, right? Like some Legos won't have little knobs on top, or some might have knobs on the side, or right. So there are definitely rules that need to be followed when working with stuff like this. But the idea is that we can take a slice of state and use that slice of state anywhere, and compose it and use it in a way that the program just doesn't care how the state is composed, and where the state comes from. That's the other thing, right? Because we could have it in the global state. We could have it, at a state higher somewhere in the component tree. We could have it somewhere, right here in the component that we're building. We just don't care where state comes from. We just know that, hey, when I need state, I ask for it, and it gives it to me. Use dash dash direct. Yeah, you're right, Chow. I needed the dash dash directory option. And the reason that I didn't have the directory option there was because I'd copied that from I'd copied the command from the NX dev tools, and then had a mess, but used the force. Thank you for that one. I'm definitely a big Star Wars fan. I wish I had the force. I think that would be fun. Maybe not for the people around me, but definitely for me. Anyway, moved this. So we're looking good here. Everything's looking good. All right. So now that we've moved this, and there were some issues that caused problems as we were moving it, we don't care about any of this stuff. So goodbye. Actually, we'll delete this. So goodbye. Delete it anyway. I don't care. I know where it's being used, and we can fix that. So goodbye. In our test setup, I think this will be fine. If we look at, probably the best way to do this is, oh, interesting. We don't have a project.json file here. So that means if we go and we look at NX, we show the project configuration. It didn't generate the project for it. So out of curiosity, if we do npm exec nx and I think it's show dash project naive option. No, I can't find the project naive option. So when we originally generated it, did it create a project.json? It did. There was a project.json when it originally created it. So let's do this. Let's follow Chow's advice. We're going to just delete this and being used by another process. Yes, it is. That's close those there. So now if I delete it, all right. Okay. Directory equals libs. And we're going to do a dry run just to make sure it puts it in the right place. We already have a library. Oh, I do already have a library named that, and we can fix that. So we need to look at the tsconfig .base again. So inside of here, we can just take that out, save that. And inside of here, do we have anything referring to naive? Oops. Naive. Oh, okay. So now we should be good to run it. But it was just picking it up from the tsconfig.base, I think. Okay, and now it's gonna put it in the libs. Good thing I did a dry run here. Lib/naive-option. Let's run a dry run on that again. And there we go. So now we're getting it in the libs naive option and how we want it to be set up. So let's go ahead and remove the dry run flag. And this is a good example of why it's a good idea to become familiar with your CLI tools, even if you're using like, plugins or stuff like that, so that you can clean this stuff up. Let's let's go back here and see what we got. So we did get a project.json, and we would definitely need the test. So we don't really need this lint here. It should be able to infer it using Project Crystal, but we're going to leave it in place. And these ones we are just going to get rid of. So we are going to say we want to discard these 4 files because we deleted them on purpose. Oh, come on. Reset the files, please. Weird. I don't know why it's not doing that, but that's okay. We'll delete them. Again, so here we're just going to say that we fixed up our project after move those changes. And then these files, we are just going to delete them. Because yeah, it's not going to let me, oh, there we go. There we go. So now they're gone. And so now if we go take a look in our directory at our naive, oops, not shared UI, at our NavieOption, within our libs, there's just nothing there. And that's the way we want it to be. So the first thing we can do is let's create a new file. This will be a TypeScript file, and this will be our naive-option. We're going to set this up, right? And so we want to export a type, and this will be our naive option T. Equals, and they're saying T or null, but that's not what we want. We want a class that has something, right? Let me snipe you. If you were to build a testing utility for a custom renderer or Canvas-based library, what would you expect the consumers to expect from the testing library? What would you mock? Oh man, that is a snipe. I mean, the obvious thing that you're going to, or that's tough, Chow, because there are a couple of different types of tests. So like component testing with something like that, because it's sending stuff to the honestly, you'd probably want a custom renderer that doesn't actually render to the screen. Because like your directives are often sending stuff to the renderer that you know, like I'm thinking about the rotation example that you did that I've seen you do a couple of times, right? Where you've set up, you've set up your Angular 3 stuff. And even for like adding light sources and textures and geometries and things like that. So definitely would want to have a custom renderer so that you could set that up and then probe the renderer to make sure that that stuff is there. And that would probably be component testing type stuff. Outside of that, I would expect it to just be normal Angular testing, right? So if I'm not interacting directly with the renderer, like if I created my own directive to work with the renderer, I would need the renderer to test that directive. But if I created an Angular directive to just do Angular stuff, then I would expect, yeah, unit test type stuff. I would expect things to just, so my testing strategy is to have as little in my components and directives as possible, and to have um, most of my business logic in services, because services are easy to isolate and unit test, and then they're easy to mock when I want to use them in other places. So I think that would be like, if I were to create, say, a service that wanted to interact with the Angular 3 renderer, again, I would need the Angular 3 renderer to be able to validate that my service worked with it. But in that case, it could just be a mock, right? Because really, I would be interacting with the public API of the service and not the actual service itself. And so in that case, I would just want to make sure that I'm calling the service with the proper stuff. I don't, unless I'm doing like component tests or integration tests, I really shouldn't care about the internals of your service. Yeah, don't render anything. Right? Component testing might be different, and that's where I would talk to somebody like Jordan Peterson, probably. Because you know that he knows a lot more about like component testing and what would be expected there. But for the most part, as long as there was an easy way, very similar to like how the router works in Angular or the HTTP client, where there's a very easy and known way to inject a mock that doesn't really do anything but gives you the ability to interact with it and then validate that what you did was correct. Jordan Powell. Sorry, who's Jordan Peterson? I don't even know who that is. I think that's my neighbor. That is my neighbor. Um, a harness, yeah, a harness would be amazing, right? Very, very similar to that. How do you deal with on-push change detection when you have, let's say, array of objects and property of some object and array changes, but the change is not detected? So Pollock, um, your question goes to kind of a deeper issue with what you're trying to do, um, and we can talk about that. Yeah, let's talk about that a little bit here. Um, so let's go to TypeScript Lang and go to the playground. And so what you're talking about is mutation, and Angular struggles with mutation. So like if I do const, test array equals this, right? And let's put in JSON chow and Pollock, right? Sure I get it spelled properly. And then let's say I do test 0 equals or we need test array, right? And for this, we'll use my streamer name, right? And then we do test array dot push, and here we'll push on Marcus, right? We've mutated this array. Yep. That's so you've already solved it. And the reason we have to do that, Pollock, is that test array hasn't changed, right? And the way we can prove this is we can say, hey, const test array 2 equals test array, right? And so after we do this, if we console log this, test array and test array 2, and then we go ahead and we run this, we'll see over here that these two arrays have the same value. And the reason for that, yeah, the reference is the same, exactly, right? So, right, you already understand quite a bit more. And so Angular's change detection looks at the reference, right? And so objects, it looks at the object reference and things like that. There's a bit more to it than that, but quite often when change detection isn't being picked up, it's because the reference isn't being picked up, right? So you're exactly right. You don't know how memory efficient it is. So what you've done is you've gone to an immutable version of you've gone to an immutable version of your data rather than a mutable version, right? And mutable versions have side effects. So me changing this is actually a side effect, right? Me pushing something onto this array is a side effect because this function is modifying this array. So it's modifying something outside of itself, right? This push function. And that is affecting the rest of the program, right? And this is a side effect because I'm modifying that's affecting something that's the rest of the, yeah. Yeah, Chow's absolutely right. You're probably fine. Where this can become a problem is, say you've got an array with 1 million items in it, right? Then regenerating that array over and over and over again is costly. And that's where you're probably going to want to start mutating the array. And if you're doing that, then you're probably going to start wanting to use, when you start getting into optimizations on that level, if you're not doing zoneless, it's best to start running those outside of the zone anyway. And then once you get back into the zone, then you're going to use the change detector and you'll probably do like a CDR mark for check, right? Which basically just says, hey, this has changed. We need to re-render the DOM tree. Yeah. Yep. And that's the other thing, right? That Chow's saying is, yeah, it's absolutely. But once you're at that level of data, right, and even 1 million is not that big. So when I worked for Fidelis, the cybersecurity company, 1 million wasn't that big. When we're ingesting like 10 million events per minute, right, over an entire network, then numbers start to get really, really large, really, really quick, right? And at that scale, you have to start thinking about data differently. But at the scale that most of us build at, right, where sub 1,000 elements, rebuilding an array is probably not going to be your bottleneck. Network time is going to be your bottleneck. Potentially render times on 1,000 elements might be your bottleneck, right? And so rebuilding an array to get a new reference isn't necessarily the worst thing. Yeah, no problem. And thanks for the question. Always two-dimension when it comes to optimization, the size of the data and the frequency changes. And sometimes, so like one of the things that it's easy to get stuck in is, we need to do X, right? So like one of the things we had is we had this list at Fidelis that displayed all the potential events, right? And you could filter those events and whatever. Um, and we would struggle with performance because we were trying to render like 10 million items to the DOM. But in reality, no human ever wants to look through 10 million events. It's just not something that we can physically do. Um, and so in those cases, right, where you're trying to render just a crazy amount of data, um, humans can't process 10 million items in a table. It's just, we can't, right? And if you ever want to, get good evidence for that, look at search engines, right? And look at the data from search engines. Search engines will tell you, hey, I found 65 million items, right? Or whatever, right? Some ridiculous number. They render only the first page. But if you look, the chances of somebody dropping off after the first page are pretty high. After dropping off after the second page are even higher. And third, fourth, most people don't make it past the third page of search results, right? Because humans don't want to look through that much data. Um, and so if the size of your arrays is causing concerns, it's also probably not human friendly. And it's time to evaluate what are we trying to give our users, and what experience, what are they trying to find, what data are they looking for, and can we make that a better experience rather than try to display 10 million items on screen. And so we would have those discussions quite a bit. Um, yeah, big data, but doesn't change much, probably fine. And that's true too. And there are other weird tricks that you can do. Right, creating DOM elements is expensive, but changing DOM elements is not expensive. So a lot of times what you can do is you can create DOM elements and then update those DOM elements, right? And there are a lot of tricks when you get to that level of optimization, but my advice is avoid it. You often don't need to get to that level. And most people, it's good to do user research, right? To find out what your users need and what they're actually looking for and how they're interacting with the stuff that you've given them. Because there may be a better way to do it once you start getting to ridiculous levels of data. So, excellent question. You sniped me away from Chow, which was a good job. But Chow, to answer your question, and I think you kind of caught on to it. I don't think providing something that people can use to that people can use to render or to get a fake version of the renderer that's not going to draw to the DOM is probably a good way to go. That would be my advice. Yeah. Anyway, to Chow's point, optimization. Once you start getting deep into optimization, size of changes, frequency of changes are often important things to note. Even like the expense of a change, right? Which I guess fits into size and things like that. So, anyway, let's get back here. So we want to export a type, and this will be some t, and it will have a certain shape. And so, yeah. That works. Making these read only. And the other thing we want to do is mark this as const, and means we have to do that. I don't need to do this. because if we look at sum, it's already narrowed that type. I'm thinking about like instances here, but really we're just declaring the type, so type can only be sum. And then we're creating a discriminated union here, and none, right? So we've got sum and none. And so our naive option T is sum or none, right? So that's our naive option T. And really, at this point, we've got most of what we need for an optional. And this file is the monad, right? Because it declares various various types, right? It declares various things, right? In this case, they're types. So we've got, a collection of types. We're close to a monad, right? This file, the naive option file, is the monad. And that's the important thing to recognize, right? That when we're talking about monads, we're talking about everything that makes up that collection, including and the functions that will get us back to that collection, and the identity functions, right? So in this case, an identity function, as a naive implementation, Copilot's doing a pretty good job, right? But let's export function identity. And that's an identity function, right? And really, an identity function just takes something and gives you back that something. I haven't had a chance to look at the example site. Let's go take a look at that, Chow. So Chow sent me over some links. Actually, before I do that, Chow, do you mind if I show this on stream? I don't want to do that before you're ready. I mean, I don't want to show these links before you're ready. If you don't want me to do it, then I'll do it right after the stream and get back to you. But yeah, I had a couple of things come up, and maybe I'll just do that. That might be the better way to go. Here's that. Oh, it's all good. Okay. Pull this off. So, that is cool. How did I do that? Anyway, this is oh, I can turn debugging on. That's cool. And you can change gravity. That's really cool. So he's got some demos here, and that's pretty cool. Like, That's hilarious. Um, at first, I thought the cube was having some physics issues, but the balls are reacting. They've got friction. Um, you know, they've I don't know if they're elastic or inelastic collisions, but the collisions make sense. They look to be somewhat elastic, but there's definitely friction going on, um, and that's cool. That's a really cool demo. Um, by the way, I need to make sure. Um, I got a follow, but it didn't come up. Where did this follow come? Oh, that one came in on YouTube. And so Eugene, thank you for that. I really appreciate it. Um, but we are we're seeing you know these are demos of what you can do with Angular 3, and this stuff is all written in pure like pure Angular code. Well, that's interesting. So you've welded some stuff together and you're looking at collisions. And so this is really cool because you can see the mesh that's used as the collision detection mesh and how it's slightly bigger than the actual object. And there's some important reasons to do this. So you can see that this mesh is sitting slightly above the plane, but this mesh isn't, and this one is. There, there are reasons for this, and it comes down to the delta steps and things like that. And so in most games, the collision boxes will be either a little bit bigger or a little bit smaller, just depending on how they want the collisions to work. But the reason these you often make collision boxes bigger is due to things like tunneling. And tunneling means that um, when it's checking the collision on this cube here, the reason that the bounding box is slightly into the plane, and you'll see this sometime in games, right? Where if the physics engine wasn't able to calculate an impact fast enough, or the impact was too fast for right, um, you'll often see that like things will be embedded into the floor, or sometimes if you mess with the physics engine enough, you can fall through the stage, right? And then you get to see, what you actually thought was a 3D world is, simple planes and whatever. But this cube partially tunneled through this plane. Um, and it really comes down to delta stepping and things like that. And tunneling just means that due to when the calculation happened, your position may be further. And there are ways to deal with tunneling based on delta steps, right? You can create tunnels and see if the tunnels interact, and then see when they interact and things like that. But that's really cool to look at the bounding boxes and collision detection there. Oh, that's really cool. Oh, see there we had some collision issues, um, and so we're getting there. There were some collision issues there. It's interesting. So a lot of physics engines allow you to specify what interacts with what, um, and so like if we look, the tail doesn't interact, but the cube does. That's a fun demo. That's how you keep things from colliding with themselves. Um, this is fun. It looks like you're culling objects to keep memory under control. Um, interesting. Curious what that one shows. Click to invert gravity. Oh, there we go. That's cool. I didn't realize that a lot of these things were still interactive. Actually, I did. Some of them I did. Um, so this ragdoll phasing through the table is a type of tunneling based on the collision model and stuff like that. And when tunneling happens, and then the physics engine, you wind up with weird stuff like this, right? Um, so I'm not a game dev, but I love working with game engines and physics engines. And for a long time, I was writing um, some neural algorithms that were based on that used physics engines and stuff like that. So um, the collision on this table looks like it's only in a specific spot where the cup was sitting, and then the rest of the I don't know what the collision model is, but very cool. Ciao. Oh, and I can mess with the light. That's really cool. Um, very cool demos. Um, I'll take a look at the rest after the stream. But let's get back into it, right? So the identity function is just really a function that will take something and then return the something that right? And identity is useful in functional programming, and it's useful in functional algebra and functional calculus. So I don't know if we're going to need an identity function here. What we are going to need, though, is we are going to need a function that will return an optional, right? A native option. And so, or naive. And we should actually rename these to be naive because we're going to be pulling in something else, right? Naive. And do I need to do that? Maybe. I don't know. We're going to do it just to be safe. And and there's a reason that none, we don't want none to be undefined or null, right? We're removing undefined or null entirely from our project. And so what we've created here is a discriminated union. So this discriminated union discriminates on the type field. So this type field here. And so like, if we write, well, we need our naive none, that's fine. Yeah. Actually, it's going to write most of it for us. This is important because this will allow us to discriminate. And the last thing, so on our types, we want a type naive option base of t. And here we'll just start with t equals any. Well, we'll say unknown, right? And we're going to add a couple of things here. So yeah, that works. And I need an equal sign here. That's why. right? And then we need a function is sum. It doesn't like this. Oh, that's why they went with objects instead of. Okay, we're going to go purely functional. I was going to try and put some of this stuff on there for chaining. But we need this type guard, and we'll see why. There's one last thing here that we want to do, and this will be our bind function. And what this does is it allows us to have a function that takes a value of some type and converts it over to a value of another type. Well, or even potentially the same type. But now we've got a problem here because our bind doesn't work. So we're gonna change this. Do I want to go this route? Because we could just have a function, and we could have a type and call this our naive bind function. And so it would take in a T and it would a U, right? So now we've got oh, not a function now, it's a const. But I'm trying to, I don't want to have to add this with a bind to it, but maybe we will. That's probably going to be the best way to go. So here we also need to add our bind function. We might have to do a dot bind. Well, we'll take a look at that here. Actually, that might work. Anyway. I think we've got our monad here. Because we've got a way to check if we have some value. We've got our discriminated union, and we've got a function that will allow us to do mapping over our discriminated union. And if you guys have any questions about what we're doing here, oh, there's a timeout that the floor disables. Oh, that's the physics demo. It's to show that the change detection and control floor works with physics and Angular 3. And that is amazing. Like, that's really cool. So, oh, and over here, I missed something. So Oleg, hey, I recognize you. Welcome, welcome to the stream, man. I recognize you. You've said some like you know you're active in a bunch of places where I'm active. So it's good to see you. Um, so we aren't using these anywhere. It's probably a good idea for us to get some unit tests in place. And this will help us to kind of solidify the idea of what we're doing. One thing I've been thinking about doing is instead of doing like a true so one thing we could do to make this a little bit more interesting is error. And notice how it's trying to TypeScript wants us to make this optional. We don't want this to be optional. So we can just say, hey, this is a naive option. And this may not work because naive option, it would be like, oh, so this can be a naive option of string. And I was worried about it being recursive, but it's not. And so here we can also say that, hey, sum, and we can say, so we'll just do we'll do error here, and our error will be a naive string, or not a naive naive option string. And by default, we'll just set this to naive none. And here we can just set error. And that should work. And the reason we're doing this is just to create a situation where, you know, we're slightly different, but really what we've kind of created is an either. And so thanks. I'm glad to see you on YouTube. I wish I had time to watch all your streams. Dude, if you had time to watch all my streams, I would be impressed. I know there are people out there that do, and I really appreciate it. And I'm very impressed that they take the time to do that. Because I try to be, you know, I try to stream a good amount of time. And one of the things that I'm working on right now, and this is where like a little bit behind the scenes, but where YouTube and like streaming and things like that, kind of where a lot of the difficulty comes in with this stuff is in the editing, right? I don't make that much money doing this. I do it more because I enjoy the community and I want to help the community out. I don't make enough money to pay an editor, and I wouldn't feel good about having somebody edit my stuff and not being paid for it. And so um, that's the long way to say that I'm working on making like some YouTube shorts and potentially like some Instagram or TikTok stuff. It will just be shorts of stuff edited from my streams that are typically the most rewatched parts, right? So, or the most clipped parts on Twitch and things like that. Just to provide short bite-sized stuff that people who may not have been at the stream, they can go in and they can get through all of the nerd sniping and stuff and be like, oh, right, yeah, he actually taught something useful. And so that's one of the things I'm looking at right now. Um, anyway, I do need to end on time today. My wife asked me before I started streaming, when I was going to start and when I was going to end. That typically means that there's something going on that I need to do. So I just saw her pull up in the car out the front window. Um, I've got about a half hour. Um, let's see. Let's write some unit tests. But anyway, this whole file is the monad. Um, so when they talk about a collection, this file is a collection, right? When we talk about endofunctors, right? Um, these are our endofunctors here. These are a way to create, right, to navigate through this collection, right? Our collection is the sum, the bind, and the none. This naive bind function is an endofunctor that allows us to do some mapping over, our naive sum object. But that naive sum still exists within this collection. So it's an endofunctor within this, right, within this collection. Naive sum creates, this creates, one of the naive options, right, a naive sum. So this is an endofunctor because it works on stuff within the collection and create, right? It's a way to map between items in the collection. It's a way to, interact with items in the collection. Naive none is the same way, and naive is sum is also a way to tell us, I've given you an option. Is it a sum or is it a none, right? And so these are all important, and but this is what we mean when we talk about a monad, right? All of this stuff is a monad. It's not just one function or anything like that. And that's an important thing to realize when we're talking about monads. Is monads are a way to work within collection. Well, within a collection. When we're talking about collections, we're talking about like mathematical concepts of collections, right? Um, and so sets are a subset of collections, right? I'm simplifying here. And we're getting into a little bit into the weeds, but anyway, this whole file is the monad, right? And so now it's time to test this. So I think testing it will help solidify this a bit more. So this is going to be our naive option test file. So now we've got our tests. So we need to describe some of our tests, right? So describe naive option. Perfect. This is our naive option. So uh, can you guys see what Copilot? Um, right, Copilot's writing a tautology here. Of course, we expect true to be truthy. In fact, we expect true to be true. That is not a useful test, Copilot. Um, so let's talk about the naive sum, right? So it should create a naive sum, right? Um, so we need to import our naive sum. So you know what? Let's go a little bit. Let's go a little bit deeper than this. We're going to go with const types equals, and here we're going to have a couple of types, right? So we're going to have a value of 42 and a description of number. Let's see what Copilot did for me here. So I did a number, string in an object. That works great. Those all look good. The other one we want to do is, yes, an array, a Boolean, a null. We don't want null or undefined, but we can take those out. I need to learn the commands to change what it's suggesting, right? And so now what we can do is, yeah, I like that test better. So we're creating more tests. So we created this types array, right? And this types array has a bunch of different types in it. And what we want to make sure is really what we're validating here is that it works for a lot of the common generic types, right? Because sometimes it's easy to write code that on the surface looks generic, but once inside doesn't. And so I like to go through and just be exhaustive in these kinds of tests, right? So right now we've just created a naive sum. And that's fine, right? We expect this to work. And in fact, let's go ahead and actually, you know what? This hasn't been popping over the top. So exec nx. I wonder if there's something in Windows that NX has trouble with, and so it keeps restarting the daemon, and that keeps popping Windows up. Here we are going to test NavieOption. We're going to throw on our watch. I wonder if I had something that. Why is that taking so much time? Oh, there we go. So the issue we have here is that the bind function isn't matching. But we can, and that works. Right now, I don't really care what the bind function does because we'll be testing it in the future. But we want to just make sure that the bind function is there. And now it all passes, right? Because now the object matches what we expect it to match. And so we're in a good state. So the next thing we want to do is we want to talk about the bind function itself. So we're going to add another describe. And yep, we want to work with a bind function. And let's see what we get here. Let's see what test Copilot wants to write for us. And this is where I really like Copilot. So Copilot created a test, right? So it should return the result of the function passed to bind. So like I don't understand why it went to all of this trouble. Because really we could just say, hey, this is what we want right here. So we're passing in the value that's a number, right? And bind. Now it's not giving us information on bind. That kind of sucks. What if I do sum dot bind? And so right away it's telling us that, hey, it has to have a number. And we can even see that it expects a number. And then inside of here, it's going to give us an error. And the error it's going to say is void is not assignable to number unknown. The type void is not assignable to type native option unknown, right? So we already aren't returning a native option. So if we wanted to like double it, we could just do return native or naive. I'm saying native, but it's naive sum. It's saying value to string, but we could do value times 2, right? And so now we've taken some value and we're turning it into another value, right? And that's the importance of bind. If we go, there we go. So here, let's look at CalDraw, right? And we're going to go down, but when we talk about monads, right? We've got this line. Everything above this line is like the raw value that we expect it to be. Everything below this line is the monad itself, right? So under here, and we can even add this text, right? So under here, we are in monad. Wow, that's tiny. Large, extra large. And we'll say everything above, oops, let's go back there. We'll say everything above this line is like user, or we'll call it raw type, right? So up here, we've got, say here, we've got the number 42, right? Well, to get from here to here, we have to use some sort of function. And that function puts us into monad land. And in monad land, down here, we are in type sum, and then value 42, right? So to get back to user land, right? This is where we have to unwrap this type so that we can use it, right? And so to get back, we have to unwrap it somehow. And the way we unwrap it in our naive implementation is we use bind, right? And so for this, we use sum. So now we are here, and we've got some function, right? And we can show what we did by saying, f of 42 equals 42.toString, right? And so this is the function, right? This is a pure function because every time we pass in 42, we're always going to get the string 42. But we have to get back, right? And this is where we have to do more mapping. So we have to get back into monad land to keep our safety. And so again, this is where we're using, and maybe I should just add the naive sum here, right? And naive sum is how we're getting back, right? And this is what the monad, right? All of that stuff is doing for us, is it's giving us a way to move back and forth between these two areas. And there is a bug, right, that we've got. And I just realized that, and that's why it's a naive implementation. But naive sum now has 42 as a string, right? And this is the power of monads, is that they're a way to move back and forth between this collection and allow us to do stuff in, yeah, you did miss the Angular 3 stuff. Monad land, exactly. Don't want to be marine. Exactly. We don't want to be, we don't ever want to be stuck here, right? Because there's power here. This collection is what allows us to avoid using undefined and null. And we haven't really gotten to the truly powerful piece, but I think understanding, right, that we need abilities to get back to the raw type, but we always want to get back here. We never want to be stuck here. If we're here, there's no such thing as optional in this land, right? We always want to be here, and that's why we're using the sum in our functions, right? And so that's why we need these abilities to move into this. So we've already validated that the number works. So now we just want to make sure that bind works. And so if we go take a look at our tests, we're failing, right? Oh, wait. Oh, never mind. I was looking at something that was saved before it was done. I was like, wait, what's going on here? Why are we broken? Wait, is this one not working? Line 17. That is not the test anymore. There we go. I don't know what was going on there, but anyway, so now we've validated that bind works, with the function to bind. We want to make sure that we can chain, so that bind should also chain. So it should chain multiple binds. Yeah. And let's get that out of there so you can see it. So we're going to start here. We're going to start with this, but we're going to add a couple of extra binds in here. So there's one bind. Let's bind. And here we'll go with value number is going to return naive sum value sometimes, I don't know, 2, right? And herein lies our issue. The bug that I was talking about is that our bind is broken. We can fix that by just saying, hey, bind yeah. And this should be a naive option. So there we go. And here we our bind function will be just a naive none. But we do want to have our error in there. And now our test will work. Because we also need the bind on naive none, so that the interface remains the same throughout, right? This is what's going to allow us to chain. And we're going to see the power of this when we get into the none, right? Because I haven't done any checks for undefined here. And if we look, our test should fail because yeah, we expect it to be 84. So we know that our stuff is working. And in fact, we could even go here and we could say, hey, you know what? I also want this to be an array. Um, so, right, so now we've created the ability to compose smaller functions, right? So this function here, we could call it double, and we could test that function. This we could, call convert to string, and we could test that function. This we could call convert to array, and we could test that function. Um, and so we've got smaller functions that can be composed into larger functions that can then be used in our option. And so we'll see now that we fail. So we're failing because we expect an array, but we're only passing the value, right? We're um, we're getting an array, but we're only expecting the value. So now, if I make that change, there we go. So now all of our tests ran. We can see that they all passed. So we were able to validate that binding works, and that we're able to map our option. And this is what's going to be powerful, because inside of here, we could return, values from arrays, or values that we're mapping. We could return values from observables. We could return value, right? And so we get some real power here. And one of the interesting things is that we've been using monads for a long time in JavaScript, and most people don't realize it. But the promise in JavaScript is a monad, and it's actually one of the monads defined in Haskell, the future. And so, right, we've been using them. Collections are actually monads, so arrays and collections are actually monads too, which is crazy to think about. But there we go. So we've now tested our naive sum, but now is the important part, right? Testing our naive none, right? So describe naive none. And the very first test is it should just create and we're going to start with the without an error, right? So hey, TBD gamer, don't feel bad about it. You're actually arriving 1 minute before I need to stop, but that's okay. Things are going well, and I'm realizing now that I need to stop because I need to go watch our puppy. For those of you guys who didn't know, she swallowed about 25 feet of cord, 20 to 25 feet. So we're talking like, I don't know, like 6 to 7 meters of a quarter-inch cord. And so she had to have surgery. And so she's not allowed to run. She's not allowed to jump. And it's really, really tough for her because she's a really, really high energy dog. And so she, yep, there's my wife telling me that I need to go watch the high energy dog. We'll come back to this unit testing tomorrow. I definitely need to go watch the dog. So thank you everybody for being here. How do I join you? Tatea, how do I join you? Or how do I join you? What do you mean by how do I join you? I think you are. You're watching the stream. Feel free to interact. If you want to subscribe, I think you can click the follow on YouTube. Um, and if you want notifications, you can click the notification bell. On Twitch, if you want to follow, go to Twitch, and there's a button that will subscribe there or follow or whatever you want to do. If that's what you're talking about. If all you're talking about is you just want to watch the streams, you're doing it. You're perfect, and I appreciate you being here and chatting. But I definitely need to end. I got to go watch the puppy. My wife just told me that. Thank you everybody for being here. I really appreciate it. The naive none is where this is really going to shine, right? Because right now it just seems like an expensive wrapper that okay, we can bind on it and do some mappings, but woohoo, right? Who cares? The only reason you have to do the mappings is because you put a wrapper around your object. So naive none is where this is going to shine and show, show what's going on. So actually, this is where the identity function is important. Because really, we could just return this. I'm nerd sniping myself, and I'm not doing what I should be doing. But there we go. So this way, we don't even have to pass the error through. The bind function is just always going to return the error, and that might give you guys an idea. But this is an identity function right here. This function is an identity function. So this is the importance of the identity function, because the bind function is just returning what is created by naive none. So we refer to ourselves. And that's the importance of an identity function in this stuff. So there's a preview. I've gone over by a little bit. Thank you everybody for being here. We'll be back tomorrow at 5:30 p.m. Mountain, where we will be picking up on unit testing our naive none, and this is going to show the power of this this, what do we want to call it, this monad, this pattern, and how this pattern will allow us to remove undefined or any from our code, or undefined or null from our code. And so join us tomorrow. If you can't, then like I said, I'm working on putting together some shorts and get them up on YouTube Shorts and stuff like that. I'm horrible at editing, so we'll see when that happens. But again, thank you, everybody. Have a great rest of your weekend. We will see you all tomorrow at 5:30.